So hello everyone. So we are learning today. This is day 4 5, and we are learning trait generics and trait bound. So um, uh, I am a learner and I want to share my learning process with you guys. So if you have any suggestion to me, you can give me, or if you have any correction to improve my learning, then I will happy to hear your thoughts. So let's um, let's jump into uh, the topic, right? So today's topic is trait and generics with trait bound, right? So okay, so now I will start reading from 100 exercise to learning Rust, right? So what is trait? First question from as a beginner, I have to question myself, what is trait? So trait is a behavior, right? Trait is a behavior, like what they are saying that cover basic Rust and type and ownership system. Okay, so they are saying this once in. Okay, so on top of trait as a concept, we also cover some of the key trait that defined um, in Rust standard library. So we will have we will have um, uh, we will cover these traits from standard Rust standard library. So first is operational trait, like uh, operational trait. So what we mean by operational trait? So first is operational trait. Okay, so first is operational trait, and operational trait, they are showing add sum. So we already know this is a similar concept of plus minus. Add mean plus and sub mean minus. So yes, it is easy to understand. And party mm, practical equation, that is I think equals to, that means equals to, right? From this is operational traits, so that means operational behavior, right? um, Operational um, um, operational trait, that means operational behavior, right? uh, okay. mm, OPARA NAL B VA. Behavior, operational behavior, right? Sorry, operational behavior. Okay. mm, so mm, operational area, right? Okay, that's okay. This is operational variable. Okay, second is from and into. For inferable conversation. Conversation. That means what we should নির্ভুল রূপান্তরের জন্য from and into is inferable conversion, so we have to understand what is from and what is into. I don't know this, that's why I have to find out first, right? From an into for inferable conversion. So let's search sorry, we will have new duplicate tabs. from from if we don't find out in this 100 exercise book, then we will search in online, right? INTTO into. So that means there is not there is no writing or reference about from and into. That's why we will search in online, or best way to fast learn, that is nowadays we should use AI. So I will just ask AI what is FRO from and to in Rust, Rust. Rust. So copy and clone. So you if we copy is easy to understand, that means copy of the variable or something, and clone, if we saw that we may think, or I am thinking, copy and clone, why they give two trait. If copy means copy some values or make extra same characters, why they give clone? It is a question just came in my mind. We will saw why they give two things, why not one. If they can easily give a clone or copy, right? So what AI say? AI say that from and into traits are baseline inferable data. Okay, transmission, inferable data transmission, that means that means for inferable data transmission, the relationship between from and into is statically unilateral in the implementation, but bilateral in the consumptions. Okay, and from you never explicitly implement into Rust standard library enforced to blank implement. Okay. Contract memory. Okay, there are raw trade signature, notice, ownership, transfer info into consumed, moved, and new memory footprint. Okay, okay, okay. So they give from they use from trade bound. Why from the core definition abstraction from trade bound. I think they give lots of garbage things, right? Yes. They give lots of garbage things. We should um so we should understand why they use WS, why they use, and how they they US use. Okay, and so um okay, that is not a big deal. So inferable conversions that uh, may be inferable conversions. Why not we should search in Raspberry example. From and into traits are inherit like the actual part of implementation. If you are able to convert type A from type B, then it should be easy to believe that we could be able to convert type B to type A. Okay. Okay. Oh shit. Oh shit, I understand that. So sorry. Um yes, from trait use to convert, right? Convert A to B. That may that is the core concept, right? That is the core concept for form. Okay, okay, that is great. Then it should be easy to believe that we should be able to convert B to A type from allow to type to define how to create itself from another type. They are saying from create allowed to a type to define how to create itself to another type, hence providing very simple mechanism to convert between several types. The numerical implementation of the trait with the standard library for conversion primitive and common types. For conversion primitives and common types, that means we use form to convert primitives and common types, right? Okay, they give an example. Okay, my string hello, this is a string, and we are this is a slice, sorry, this is a slice, and this convert in string, right? Okay, we can do something similar, define conversion our own type, convert form. Okay, structure number, so implement from I 32 for number. Okay, okay, that is it difficult. I think it is a difficult thing to understand. So we can do something similar, define conversion, similar defining the conversion for our own type. So we can mm, we can um, we can let's say this part is slightly okay, slightly interesting, because we have a structure that is I32. Then why we need to convert this from I32, or what is going on in this code? I didn't understand. Number is 30. So if I ask on the Gemini what is going on in this part, what is going on in this PAR part, and WSY we AR CON PERTI in the TYP steps. Okay, so this is how we should use the AI, because AI is our co-pilot. Okay, it will help us to fast learn. And what you're missing, fundamental architecture, philosophy, or system types. You are not simple converting type, you are executing semantic promotion. Row I32 occupied exactly 4 byte of memory of structure. Number also occupied exactly 4 byte of memory. At the machine code level, the execution cost 0 log cycle, it is 0 cost abstraction. Here exactly what happened in the block, what is mandatory for our infrastructure. Structure breakdown, what is going on in this part. Okay, the contract contract binding, right? So implement form for number, blind the standard library form trade to your specific target structure. Declare that acceptable in input for this specific implementation. Construction self implementation primitive level self suitable trade. So in the system mandate, why are we doing this? Okay, I have to know that. So in the elite DeFi environment, raw primitive like I32 or U32 are catastrophic liability. They carry zero semantic weight. This is new for me. I never hear this zero primitive. Okay, there is no importance of zero semantic, right? The considering raw would be represent a amount of USDC, amount of euro C, Solana clock time, and slippage tolerance percentage. If you are right core, okay. Okay, compile it, and transition will execute, but the protocol will collapse. Why? It tried developer will accidentally pass a timestamp into a parameter expecting a U30 USDC balance. The compiler will compile it, the transaction will execute, but the protocol will collapse. That means compiler is in that time compiler will write and give you to execute the code, but the system will collapse. We execute those structure conversion to enforce domain drive design the network type pattern. So by defining number or in our word structure is like number or no timestamp strictly map for mapping the form implementation. You established a type safety forness. Okay, I understand that. Okay, so getting to compile any possible from to exactly graded as a number if rule number cannot be negative from implement and architecture. You should use failable based on the system rules from automatically guarantee that reverse info. How would you write main function? Okay, so do you understand what they are saying? So they are saying that uh, if I have raw primitive like I32 and IU64 are and they are carry 0 symmetric weight. Okay, the raw IU64 could represent the amount. Okay, it can represent the amount. The Solana clock timestamp, slippage and tolerance percentage. That means it can have this the raw 1 minute. So raw U62 could represent a amount of U62 and amount in euro C, a Solana clock timestamp and slippage tolerance percentage, right? So if you write a core liquidation function that accept a raw U64, a tier developer, here is the main core concept. If you write a core liquidation function that accept raw U64 and a try developer will accidentally pass a timestamp into a parameter explicitly expecting a USDC balance, because U64 can accept timestamp slippage percentage if a developer just pass timestamp into USDC balance. In that time compiler will compile because it can and the timestamp is also U64. The transaction will execute and the transaction also will execute, but the protocol will collapse. That means the core architecture, the core system will collapse. By defining number here, by defining number by defining number or in a word structure like collateral number or normalization timestamp, the strictly mapping the form implementation you establish type shape for fortress. Okay, compiler enhancement. A function require number. It will strictly reject row I32. You cannot accidentally mix them. Sanitization check from a block become the single verifiable gate whether raw external data is officially recognized by your internal system. That means method isolate. You can implement specific mathematical trait like calculate interest on number that you would never want to attach to global generics I32. So the moral of the story is sorry, we use form for type conversion, and we use here we use I need this just from I need this example, because without example we can't remember what we done here. So here is the from. We explicitly saying we are implementing form is I32 for number. So if I go here, and okay, okay, okay. So we have form, and we are explicitly saying that this structure what we are implementing, this is I32 the structure accept I32 for form iter, and we use this method form. This is form method, and this is form method, and this is form method, and self okay, the number value item okay. Right. So we understand that if we want to explicitly target our structure, if we want to target our structure, form is the best way to target, and it is also help us to convert types, right? So now we will jump into part. Okay, so into trade is simple reciprocal of from trade. It define how to convert a type into another type. Okay, calling into method typically require us specific the result type, and compiler unable to deterministic most of the time. Okay, implement. Here you can see implement into number for I32 okay. Form and into interchangeable. Okay, we can use form and into our design complete complementary. We don't need to provide implementation for both trait if you have implement. Okay, that means we can use either from or neither into. Okay, that means we should not focus too much into this part. Okay, here you can see clone and copy, right? So clone and copy, we are learning trade, and trade is most important. I am just astonished about that. If I can't understand the trade, then I never understand the Rust code. So that's why I am focusing too much on this part. Okay, copy trade allow simple copy uh, when dealing with resource transfer sometimes not copy to resource. Clone trade help us to do exactly this. Most commonly we use clone method dot clone method by the clone trait. By the clone trait we use dot clone method by the clone trait. Okay. Okay, here you can see copy trait allow a type to be duplicate simple code. We all know that, but with additional logic require with additional logic require whether the implementation problem. Okay, importance copy requires clone, and any type that implement copy must also implement clone. This is because copy is defined as a subtrait of clone. Okay, this is important. I never know this. Okay, copy is a subtrait of clone. That means parents and children relationship. Okay, okay, that is good. um, okay, for not all the types can be implement copy. A type can only be copy if all the components are copy, so it does not manage external resource like heap memory. Okay, here they give big code chunk of code. So we so it is easy to understand that copy just used to valued and differ cognition and size to make type which is unknown size. It is important because many time you will see I face this. I don't know you, but I face this problem, that is size unsize, right? In a method I use primitive, sorry, why this. Okay, in size unsize, scale type, we know this um, single integer, unsigned integer, floating integer, and characteristic boolean, and unit type. That means those only possible value is an empty tuple. uh, this can help us in future. I don't know, but I think they will help me in future. Okay, that is great. It is easy, but I am although it is easy, but I just um, take a notes because it may help in future. Send to backward. Okay, sending to backward. Okay. um okay, sign integer, answer floating. It is easy. And character unicode scalar value like for with boolean either true or false. Okay, it is easy to understand, and I am not deep diving into this. Drop for customer custom clean logic. Drop for custom clean logic. What they are saying this, that is uh, drop great drop. Okay. The drop trade only has one mention drop, which call automatically when a object goes out scope. The main use of drop trade is to free the resource implementation instance owns. So why we need drop? Because after executing the function, Rust automatically destroy the variable or destroy memories. Why we need drop? I have that question. Let's find out the question and find out the answer. mm. Box, vector, string, file and process are some example types that implement the drop trade for free resource. Okay, manually implementation, any custom data type. Okay, if we want to manually drop, then we can use drop trait. Like here we can use drop table name and implement drop for droppable. This trivial implement of drop adds print to console. Okay, it is just print in console. Let's say block A, B, block C. So exit block B, dropping drop C, just exit drop B, exit block A, dropping block B, exit. Okay, here is something. First we are printing exit block B, this part, right? And yes, after we drop C and dropping D, dropping C. So okay, so we are sending this, dropping C and D. So we are dropping this part. First we execute this print, and after we are dropping this part. This is dropping D and dropping C, and just after that we execute A, yes, and then drop B. Okay, it can be manually dropped using function of A. If we don't use drop, what can be done? Okay, drop A. I have question in this. If we don't use drop, what will happen? Implementation drop. What will happen? Okay, that means executing block B, just exit block B, just exit block B, exit block B. First line is this. This is existing block B, and just block exit block B, just exit block B, exit block A, exit block A, then just exit block A, just exit block A, and then the end of the main function. Okay, I understand that. So okay, I just understand this part. So if we want to drop this from our memory, and drop function, and try this line, committing this line. Okay, drop 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 in or from what drop, sorry, I think I just mistakenly sorry drop for is loop, right? It is using loop. Okay, so they are saying that you can they are saying that if drop variable drop function drop A, drop A, try committing this line. That means if we want to commit this line, if we commit this line, what happened, then what will be the change? Okay, let's see what is the change, and let's find out the answer. So what change? So dropping B, drop B A, okay, okay. Do you understand that we drop this part and at the end of the total execution? right? If we use if we don't use um, if we use this drop a, then it will drop immediately, like in a, okay. Understand that if we want to drop a variable, then we can use drop uh, this drop uh, trait. Yes, we just complete the traits in Rust. So here is the core thing in Rust. See, we have basic things, add, sub, and partial equation, and from is known for type conversion, we know, and clone is for copying value, we also know that, and defer sorry defer sorry copy, that is why I don't use oh, dereference, sorry. Defer means dereference. Okay, I understand. I just forget that. Size, we already know the size. There, those are the size. In sing signer integer, unsigned integer. So, okay, floating point, we already know that, and drop is used to clean up from the compiler. Okay, so we already covered this trait, and I don't use this Raspberry example because Raspberry example is huge. It is huge, right? And I think it is not feasible for beginners like me to use this book. This Rust exercise, or to learn 100 exercise, that is more likely useful or lightweight for me. That's why I doing this on. Now it is time to learn generics. Okay, generics is very important concept, as long as I know, because maximum time, sorry, G N G N A generics. Okay. Okay, because generics can be very critical for if you are new in Rust, and like me, I saw some exercises, and they are pretty confusing. So normally it is, if I described generics, what is generics? Generics is a just generics are a placeholder of types, are filtered by the cell or function. And the core thing, the funny thing is, if we just learn the definition or see the definition, we just feel that it is too easy to understand, but on the implementation part, it is too hard, because there is not one type of generics, there is multiple generics is used in the code for reusable concept, from the reusable clean code concept. The function will generics parameter is polymorphic. It can call by definite types and compile with the generics. Okay, blah blah blah. And RPIT, if you read RFC or deep dive about Rust, you might come across acronym RPIC. It stands for return position implementation thread. Okay. Okay, generics. I have to find out the generics. Sorry. So I have to find only generics, not trade implementation. Generics programming. Okay, we have to. This is the generics programming. So we can do better using generics. Generics allow us to write work with type parameter instead of concurrent type. Okay, and look, that's why I just say that generic using generics in code look like it's too confusing and difficult to understand. But as far as I know, if we deep dive into generics, it will be easy for us to understand. So generics allow us to write code type parameter instead of concurrent type. Okay. Print if event. Okay. A print if event is generic function. Okay, it is not try to a specific input type. Instead, it working with any type t that implement the is event trait. Implement the is event trait to specific input type. It is not try to specific input type. Okay, that means we can give any type of input instead of it working with type t. That means one type at a t type is there. Implement the is event trait. Implement the is event trait. Okay. Implement the debug trait. Okay, so what we are using, is event trait and implement a debug trait. The contract is expressed with trait bound t is event plus debug. The sum plus symbol is used to require that t implement. Okay, here you can see t is event plus debug. So do you understand what I am saying, or am I understand what I am saying? That is, a concurrent is expressed with trait bound. Okay, we will learn trait bound next. They are saying concurrent is expressing with trait bound t clone is event plus debug. Okay, plus symbol is used to require that t implements multi-thread is event debug. Okay, plus symbol is used to require that t implements multiple threads. Okay, t colon event plus debug is equivalent to t implement. Okay, so um, if we um, if we okay, and here is n is, here we pass n is event, we check it is event or not, and if it is event then it will give us is event. um, okay, okay, so it is um, easy, but we have to understand there is two part, that is this is the generics, and we implement these generics on this input parameter, and here the generics is event plus debugger, and we just print that with debugger. If we use driver, then it may not need it, right? So yes, that is the core concept of generics, and we already done this part. Yes, trade bound. So trade bound, what purpose to do trade bound? Serve in print if event. What purpose do trade bound serve? So why we need trade bound? Why we need trade bound? Okay, what purpose do trade bound serve in print if event? To find out, let's try to remove them. Let's try to remove them. What purpose do trade bound serve in? Okay, so here we can see this is the code. Here we just have a function that is called print if event, and we pass a generics, and here is the implementation of we pass this generics in this function, and if n dot is event, then public print n is event. So this code would not compile. Why? Because no method name is event. So found for types parameter t in the current scope. So they are saying the method is event not found this type parameter. Okay, that means this type parameter don't have this is event method, right? Okay, n dot is event method not found in t. The t does not implement debug. Okay, print, t means type, right? Type type print and clone question is event. T cannot be formatted using clone because it does not implement debug. That's why we use uh, this debug, event plus the debug. And consider restructuring type parameter t. The print consider restricted to type parameter t, and the print if event. Okay, we can use str formatter debugger, or we can use this inline thread bound. Okay, so this is this is what without thread bound. Okay, we know that we can use thread bound set only used to ensure the behavior required by the function is present. Okay, syntax inline thread bound. So inline thread bound means when we implement that, will just add it. This is where was, and if and the thread bound are simple, you can inline them directly next to the parameter. Okay, if it is simple, we can inline them directly in the parameter. Here you can see is even why, what is even is a what library function. Is even is a library function, library trait, sorry, is even is a library trait which have is even for a method, right? Is even is a library trait. So we can ask Gemini what is even. What is okay, so they give two syntax. One is I can directly call in the pass in the function, or I can use in parameter inline and like that, or syntax meaningful names. In the example above, the t is parameter parameter using parameter name is a common combination, then has only one type of parameter. Nothing stop you to using more meaningful thoughts. Okay, that means we can use meaningful parameters, right? Okay, it is actually desirable to use meaningful names where multiple types parameter is play out and the name t does not convey enough information about the types, roles and functions. Okay, that is great. Okay, yeah, okay. If you are Genesis execution corridor, MT will be capable to check each event. It is also then okay. Zero first trade bound. Okay, by applying using your established a trade bound store. I am just adding trade bound. Trade bound means okay. I am trade bound means I am adding a operational boundary. Trade bound means I am adding a operational boundary in a variable. Trade bound means okay, then AI trade bounds and I am using trade bound means I am using trade bound means I am trade bound wherever I am limiting limiting I am means I am limiting trade bounds means I am limiting what bounds means I am limiting the behavior of the BARI types types. Okay, this is from my side. Okay. Okay, so we function sign is king. You may wonder why we need trade bound at all. Cannot the compiler infer the required trade from the function body? It could, but it wouldn't. The relation is the same of function is connected between the caller and cell, and term must be explicitly stated. It is allowed to be better error message, better documentation, and less in unintentional breakage across the version and fast compile time. Okay, let's see. Trade bound okay, here we are giving a trade. We are passing a generics and here you can see a necessary treatment to mean so that compiler successfully. Okay, this is a challenge for me. Let's see. Copy change the compiler API but that comes with sorry, we will practice this trade bound a trade sorry rust cd KDIR mandatory BAS I see CA CPT concept CD MBA FI CBC and CPT concept. Okay, we will make a directory that is called mkdir, a directory that is called trade bound, trade bound, BOU and the bound, right? Trade bound or bound, bounds. Okay, okay, CD trade bounds, CD trade bounds, CAR CO cargo in it. Okay, trade bound ls CD src. Okay, CD src dot main ls main dot rs and one. So get mirror as. Now we want to open, say, ODE port. Okay, here is the main.rs iteration. Yes. Okay, so we will use this, sorry, this main function in this okay. Here the AI suggests me that partial or orient, partial orient. Okay, let's see what this partial orient do in the real time, right? Partial orient comparison, use for comparison, right? So I want to run this program, cargo run, and what we just done in here, we pass to number and we will check whether it is big or small, right? And run. Okay, minimum of 2 and 20, 10 is minimum. Okay, if we don't use this partition null order, then what will happen? Let's see. We can't use this operation for our task because this is the trade. If we don't use the trade bound of this, we can't use this trait. So the core concept is, if we want to use this trait, we have to use them the trait bound, right? So okay. So do you understand? I am clear now. uh, I will go through trait, trait. Okay. So if we those, they are the trait, right? They are the trait, and if we want to use uh, sorry, if we want to use sorry, something like that. To use trait previous trait, there's a trait fingerprint place already, so operators. Okay, and operator OP RATOR. Operator, sorry. Operators. If we okay, operator overload, operator, arithmetic operator, updated operator, not like that. Operators. Operator. Okay, they are the arithmetic operator. So types, if we want to use them, we have to implement which trait bound. If we want to use trait, if we want to use operator, then we have to use trait bound, like those things. Okay. So I am so this is extra topic, but I think I should go through this part, because it is, if I don't use, or I don't go through this, then it will hard to understand. So why we are using traits and trait bound, right? Okay, so trait bound means limiting waiver of types or trait or trait TRATE trait. It is I think trait bound is clear. Like this is a trait, trait, and if we want to use this trait, then I okay, operator. So PARATO or operator trait. operator. So now you can understand why we are using this trade bound. So okay, here you can see the moral of the story is small. So the moral of the story is sorry um, okay, the moral of the story is, if we want to use operator, then we need uh, a trade. That trade is we have to bound with the operator. So bound means we have to connect the trade with the operator. Here you can see this is the trade, sorry, this is the generics, and we are using this whatever this question, debugging operation. We are using debug trade, and because we are using debug trade, or we are using event trade, that's why sorry, I have some mistake on this part. We are using event, right? Event function, and it came event function, it came from event trade. So if we use debug in our program, then we have to use debug trade bound, right? A debug trade, right? So we are using I think it is too much confused for us, because trade bound, TRA trade 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 bounds. Yeah. Here okay, this is the copy. This can be used as an example here. Okay, it will much more easier and students to understand. TRAI detail and the bounds. Okay. Okay, I understand this part. Okay, here you can see. Okay, here you can see we are using this sorry, this is an operation, arithmetic operation. Sorry, this is logical operation. So if we want to use this logical operation, we have to add this trade bound, and we already saw there is the traits. Let's trade trait. Okay, you already saw this trait. Sorry. So those are the trait. Okay, Ctrl G and send to okay. Okay, here you can see this. Okay, here you can see the trait. Sorry. So the traits, you can see the traits, and now it is easy to understand. So this is a logical operation we are doing in here, but for this logical operation we our compiler doesn't know what this sign mean in our Rust program. So that's why Rust programming language ask me to explicitly said what you mean by that. So if I want to use this, I have to give instruction to Rust compilers. I have to say this type, and that means this type I am comparing these numbers with one another, and I am using partial order. Okay, after I explicitly said that, my Rust compiler understand that I am just comparing two similar type at a time. So this is the meaning of Rust trait bound. That means we have trait and we just bound it in our program. That is why it called trait bound. We are clear. I am clear. So because it is for me, I am just sharing my learning steps with you guys, and that's it. I today's 3 topics are covered and my topics over. So if I shortly describe, Rust have lots of logical trait bound, or logical operation like add, sub, partial comparison, or format change, clone. So Rust have those type of behavior in code. So the behavior means trait. This is too easy. The behavior means trait. Okay, so and the generics is a placeholder, right? Generics is a placeholder So we just use as a placeholder, but it is important for us because we without generics we can't write dynamic programming or clean programming. And if we want to use if we want to build production grade, in that time we can use reusable code, and that will help us to code cleaner and smaller, right? So generics is that part. It is just a placeholder on the places of types. So how generics we write, we use first bracket, second bracket, colon, inside that we just write the generics, and we just explicitly say the types, and then we just use it in the function or anywhere we want. So trade bound means a trade bound means my code have some behavior like increase decrease. My code have those type of behavior. I have to explicitly tell or told that if um, if I compare two types, then I have to implement the trait, the behavior of that code. So trait bound means behavior, attach behavior in code, that is the trait bound. So we just complete them. Yes, our so we done trait, generics, and trait bound. Hopefully I am also building a project based on Rust, Solana. So we will implement these topics in the project. Okay, thank you. Bye everyone.